Good afternoon and welcome to the afternoon session of Sustainability Connect. My name is Paul Wolf and I'm the newest member of the team within the Office of Sustainability. I have a very unique role here that is focused on cultivating the campus as a testbed platform. This is also referred to commonly as living lab research. So for the last several months, I've been collecting stories of the amazing work that's been going on right here on our campus. And today, as part of this panel, you will hear stories of living lab research from the people that know them best, the students, the staff, faculty, administrators, and scientists involved with this transformational work every single day. So before we begin the panel, I'd like to draw your attention to a packet of cards on your table. Does everybody see this packet of cards on your table? These are learning adventure cards. They're kind of like baseball cards for researchers. But instead of tracking runs batted in, or statistics about offense, defense, and base running, the adventure card records research themes, partnerships, and outcomes. So each of these cards will correspond to a case study that we're going to hear about as part of the panel session today. So feel free to check out these during the presentation, and afterwards, if you'd like to take them home, feel free. They make a handy bookmark as well. I've collected about 20 of these adventures so far, and my intention is to link them to a database, so ultimately, all of the information collected will be searchable. Later this summer, in collaboration with ESI, I'm working on a geolocated phone app tour, so you'll be able to actually go to the place where the research happened and experience it firsthand. So without further delay, I'd like to introduce Joe Higgins, who many of us know already, but in case you don't, he leads the Information Business Operations team that is integral to MIT's planning, construction, operations, and sustainability initiatives. Prior to that, he has had many roles within the higher education, financial services, and research sectors. Most recently, he was involved with the precedent-setting negotiation of the Aggregated Partnership PPA project, of which we have our special guest, the solar panel, down at the other end of the room, directly from Summit Farms. Joe is a part of that team, and I'm just thrilled to get to know him and work with him on the Living Lab project. So let's welcome him now to the stage. Joe Higgins.
Thank you, Paul. So with that, I think if we could just ask our panelists just to come up here, I'll do some brief introductions. So I think the thing that really got me excited about this portion of the program is this is the what I call the muddy boots portion. We have a lot of ladder climbers, hands-on wrench turners, chemical mixing folks here, so this is kind of like where the real fun stuff happens. So I thought it would be fun to just kind of get a sense from the room, because the testbed environment is a linking of those that kind of are day-to-day in the operations world with the academic and research world. How many folks here are from the operations kind of day-to-day administrative side of MIT? Okay. And if you put your hands down, now you assume the rest from the academic and research side today. All right, so it's about 50-50, so that's fantastic. So what we learned a little bit about this morning is our testbed environments here at MIT are as much about social science as it is about solving problems and technology. It's about being curious, asking questions, trying things out, and getting other people to do it with you and making that connection can be a bit of a social science at some times. So we're going to hear a little bit about the stories and how that happened from our panel. So with no further ado, let me just jump in with some quick introductions. Rachel Perlman is a PhD student in Engineering Systems Division. She's also an MIT Office of Sustainability Fellow. Rachel's interests are in sustainable materials management, and she'll be sharing with us a case study for MIT's campus material flow analysis. So looking forward to that. Next, we're going to have Kripa Varanasi. Kripa is an associate professor from MIT Mechanical Engineering. Kripa's interests are surface science and engineering, nano-engineered surfaces, and their applications to energy, water, agriculture, aerospace, and a number of other cool areas. He'll be sharing with us some research that they're doing with the facilities group on water-saving technologies that we use here in our central utility plant. Third will be Maurice Peters, research scientist here at MIT Mechanical Engineering. Maurice's interests are photovoltaic development and opportunities to extend research fabrication of solar cells, the development of those systems, analysis of how these systems work, and how we communicate that to the layperson's audience. And he was one of my colleagues in the testbed around the solar project, North Carolina. And then Pam Greenlee, the Associate Director from the MIT Office of Environment, Health, and Safety. Pam's interests are in green lab certification. I've heard her talk passionately many times about it. Laboratories are a keen interest of mine and MIT's, and she'll talk a little bit about the certification program, how it's gone, and now they're going into the phase 2 and what's going to happen with that. So before jumping in with Rachel, just to provide maybe a minute of context on the living laboratory. So we all know the people of MIT are at hard work every day solving some of our planet's sustainability challenges. But what we saw was a call for action from President Reif back in October 2015 that really kicked this off and accelerated these testbed environments. With fresh energy, urgency, and a vision for constructing a living laboratory here on our campus. And since then, Paul pointed out, we've activated over 20 initiatives in our living lab in just those very short many months, and hopefully many, many more to come, and that's what our next phase of today will be launching into. So these 20 initiatives are labs that allow us opportunities to test ideas and innovate new thoughts, technologies, and practices, opportunities for hands-on education for many of our students and researchers here in climate science and sustainable design, opportunities to incubate curiosity, also opportunities to improve our campus in terms of efficiency or cost savings or emissions reductions, and lastly, labs that help us showcase to the rest of the world what is possible. And I think that's where things start to get very exciting. So each one of these test beds is an adventure. And I think that's what we're going to be hearing from our panelists today, is the adventure that they went on. So there was a spark that got things started. There were some very different partnerships that were made along the way and the networks that they activated. And then a little bit of kind of where they're at and what's next. So with that, Rachel, would you like to start us off with your testbed experience?
Yeah. Do you want to advance the slides?
Oh, yes.
Great.
I'll give you the clicker if you want. You just
perfect.
push the one on the right.
So hi, everyone. I'm Rachel Perlman. I am, as Joe said, both a PhD student, and I'm also a student fellow in the Office of Sustainability. So those are my dual roles, dual hats today. I'm going to be telling you about my project I've entitled Decreasing the Materials Footprint of a University Campus, Case Study of MIT. So here, MIT as a system is the test bed at hand. So just some background on my research. The goal of the project, and this is a 4-year project more or less, and I'm about halfway through, just so you know, I don't have my final results for you, unfortunately. Part of the goal is to characterize the material flows of MIT, do a material flow analysis, basically map out all of the products and materials we're consuming as a university and all of the waste we're disposing. So it's a pretty big undertaking. Hopefully it is enough of an undertaking to qualify as dissertation worthy. And in doing so, I'm also looking at the organizational structure of disposal and procurement decisions. So what is, going back to, there's a social science aspect to this research, certainly. I'm also not only quantifying the kilograms or tons of material coming in and out of campus, but also trying to translate that to environmental footprint. So whether that's kilograms of CO2 or toxic quantities in terms of dioxins. And lastly, this part ties in heavily with my work with the Office of Sustainability. I'm trying to recommend and identify institutional opportunities for reducing our material footprint, whether that's via logistical changes or material substitutions. So I'm going to talk about briefly 4 testbed elements of our work. The first is the collaboration with the Office of Procurement. There's some individuals from procurement here today, Gilles and Cecilia, I believe, and maybe others. Material flow analysis, my waste audits, which I'll explain what a waste audit is, and our collaboration with facilities on trash recycling and compost, and I believe Ruth and Jared are over here representing facilities recycling, and there may be others from facilities. It's great to have you here. So the first, the collaboration with procurement. One of the things we're doing is working with procurement, the Office of Procurement, to use a data-driven approach to look at how has MIT spent its past 10 years purchasing materials and products from the e-catalog. So this visualization gives you an example of the type of analysis we're doing with this data, where on the y-axis, it's the number of purchases, the quantity of purchases, and on the x-axis is different years. So as you can see over time, where the total number of purchases has increased, and those colors just represent different material categories. So this helps us. Procurement's data, historical data, is a huge help for us to create a material flow analysis of the university, because there's so much data that goes through the e-catalog system. Not all of it goes through the e-catalog, but a lot. And so again, this data can be used to quantify the number of dollars we're spending on different types of products, and also then use the product information to estimate material footprint and greenhouse gas footprint information. And we're looking to see trends. Are we purchasing more of a certain item over time? And again, identify opportunities for reducing the environmental footprint of our purchasing while still retaining the functionality. The second aspect, it ties in directly with what I just mentioned, using that information to create what's called a material flow analysis. Visually, it looks something like this. You'll see it on the Paul's cards. The idea is on the left-hand side, we have the material inputs, the purchases. In the center, we have the use category, and on the right, we have the form of disposal. The thickness of the line is to scale with the quantity of material purchased or used that's flowing through the system. And this data is made up just for the purpose of this visualization, but it shows you what the ultimate goal of the material flow analysis is for the entire university. The waste audits are another test bed element. We're working with Ruth and Jared to have these waste audits where we involve students and staff, and we basically sort a bunch of waste by hand and weigh the different components to get a sense of the composition of waste on campus. This has multiple purposes. One, it gets students engaged in the process and thinking about waste. Another is that it increases awareness about how to source segregate. And the third is that it provides data. So multi-purpose. And just a little plug, we have our next audit coming up on the 18th, so if you're interested. Here's just a sample of the kind of results we can get. Just to point out, this was one waste audit we did last summer, and the Koch building had, for instance, a contamination rate of recycling of only 5%. So that's pretty good. The last thing I'm going to talk about is our collaboration with Facilities Recycling Office. We're again using a data-driven approach. This image is of the data hub, which Midos's staff, Derek has been working really hard on. It allows us to display the waste data that facilities has been tracking for a number of years, so kind of showing off the data that has been collected that maybe a lot of people don't know about. And we're trying to learn what waste streams are most costly to MIT and what we're generating the most of. So thanks for your attention.
Right, cool. Thank you for having me here. So I'll tell you a little bit about a project that we are working on, which kind of got, we were looking for a pilot to do, and fortunately I was sitting next to Julie at a dinner table, and and that sort of snowballed into a very interesting and I think a very impactful project where we are very fortunate to be working with some awesome engineers from the cogen plant who have been really helpful in establishing some baselines and experiments for us. So what we are trying to do here is, if you think about the energy need, right, for the planet, it's only increasing. And this is a chart out of, I think, either DOE or the International Energy Agency, showing that our energy consumption and our sort of install base is only going to double in the next several decades. And if you think about who consumes a significant amount of fresh water, it's power plants, right? So you see that they take up 49% of the total fresh water. This is in the States, but similar data across globally. And the economic costs associated with that, this is globally about $75 billion per year associated with the water prices, and it's only going to increase. And then there are other issues, such as regulatory issues, where you have plumes that come out of these cooling towers, and I'll get to what a cooling tower is shortly. If you walk along Vassar Street, right next to the cogen plant, you see all this white haze. And some people think it is smoke, but it's actually just water coming out of a power plant. We developed this technology in the lab over several years, maybe about 4 years or so, and we were looking to also gather a lot of business data to see if we can actually build a business case and take the technology out to market. So this is some example from a cogen plant right in Kendall Square here, which is operated, I think, by Veolia. And you see that they consume as much water as about what 100,000 people would need. And the amount of energy that goes into it, both procurement-wise, is of that order. The amount of cost per year is about $5 million, so it's a very significant problem. And then also, locally, you're not allowed to sort of have plume because City of Cambridge has regulations around that. So let's look at how cooling towers work. So what happens is a condenser in a power plant is where you're rejecting heat, and so then all that heat has to be then dissipated into the environment. So what you do is you run another cooling cycle where water is sprayed and you evaporate, and then there is this fan that basically is sort of letting all that vapor out. And you see that you create sort of these plumes, and you're losing on the order of 2,000 gallons of water per minute. And so that costs about $5 per 1,000 gallon. So we actually built a prototype in the labs to sort of mimic this cooling tower. And over time, because you are constantly evaporating water, what happens is water starts to, as you're evaporating, salts start precipitating, and so there's a blowdown cost. And so people have to figure out how to sort of then retreat that water. So overall, you're looking at basically, roughly $7 per 1,000 gallons of water. Missing something, but basically then you need to add sort of makeup water because you are sort of blowing down all this water. So our solution was based on an electrical technology, and I'm not going to go into a lot of detail about this, but we essentially charge the droplets that are sort of coming out, and then we're able to capture them. And we are then, the water that you're getting is very much like distilled water. It's fairly clean, and then you can use it again to either pump it back into the boiler or, re-inject it and sort of, remove the whole idea of blowdown and so on. So here is sort of a demonstration of the technology where, so this is, without the electrical field on, and as we switch on the electrical field, you see that whole plume has been captured, right? So. And then you start collecting all that water. So we built a prototype. We got a lot of data and shows basically all the science works. We can scale it, and we can actually go fit it on a cooling tower. Having started several companies in the past, what's really useful when you take something out into market is to show a test case. Because for people, it's especially for power plants, they're very kind of risk averse. So if you have demonstrated it somewhere, there is so much more readiness to accept in the marketplace. So this is kind of showing more details of how this is captured and so on. So we've been able to improve the efficiency of almost 80% in this case using our technology. So what does this mean? So this means, for just a single power plant, 250 megawatt, you're looking at 150 million gallons of water saved and corresponding savings in power. So of this $1 million saving, the energy or the amount of sort of energy that we use to run this is actually very little, because we are operating at the thermodynamic limit of capturing these droplets. So we've gotten a lot of interest from various power plants. Of course, everyone wants to see, has it been implemented somewhere? And from a sort of whole pricing and competition point of view, we are very, very favorably priced, both from a CapEx and OpEx scenario. And the market, definitely is huge worldwide. Here in the US, you're looking at 900 gigawatts of power, but $8 billion in water savings that we can affect, right? And in growing markets like China and India are there. So we had this great thing. We want to demonstrate this. We could have started a company, and we would have gone through a lot of pains of finding who would pilot this. I've gone through this before. And so that's why I say, it's very fortunate that I met Julie, and then we're thinking about how to sort of, really utilize what we already have at MIT and sort of make it a win-win, which is, from an MIT point of view, it'll be a cool new technology that we're going to demonstrate, but more importantly, we are going to sort of, save the water footprint and really, improve the water footprint and the energy footprint of the campus. So that kind of got us started on this path, and we met a bunch of folks from the Cogen plant, John Sepich, Ken Packard. I remember a room where we were all crowded and talking about stuff. Paul from the sustainability office is incredibly helpful in coordinating and connecting us. And we met these two great engineers, Seth Kinderman and Patrick Karalakis. I don't know if I pronounced it right, but we got an awesome, sort of data, sort of training on, how various. Because I was at GE before. I've looked at power plants, but this was sort of really taking us into the heart of everything. So we climbed up all these. Climbed up onto the top, and this is a picture of all of us there. They're explaining us various things going on in there. And as we speak, we are actually setting up various experiments on the cooling towers up there, collecting valuable data. We already have a lot of data that they've given us. All of this has become really, useful in sort of putting all this together and fundamentally de-risking the technology. And then, we are able to then sort of take it to. We hope we can take it to market and really have an impact on at the energy water nexus for the power industry. So after that, as you can see, there's a lot of great participation from both sides, and so on. So thank you very much.
So yeah, hi, good afternoon. My name is Maurice Peters, and I'm here to talk about the solar testbed here at MIT. And in a way, this is not a new testbed. MIT has had solar panel arrays on different rooftops for, I think, about 15 years, if I heard it correctly. A quick question here: who here knows in this room where they all are? Well, at least a couple of people do. That's good. But I think this is something we'll have to work on. So in a way, this is quite an old testbed, but with the recent power purchase agreement, there has certainly been some new impulse in the development of testbed at MIT. And with the power purchase agreement, we, of course, now have a couple of very different opportunities that we can talk about. So in that sense, this is really something relatively new. And for something new, I will not be able to show you many results, but I can talk to you about opportunities, which is very nice. So this is, in a way, the simple story of solar. Simple because you can see that it's almost two straight lines that I'm drawing here. And it's a success story. The blue line is the cumulative installation that we've seen over the years. This is a logarithmic scale here on the y-axis. So we've had a 29% growth year in average over past 25 years in installation of solar. So when I started, which was around 2000, there weren't that many big solar plants around yet. But as of today, solar is the most installed new electricity source in the world, and we're providing 1% of global electricity with solar, and there are going to be many, many hundreds of thousands of solar panels installed this year. So this is how the technology has evolved. On the other hand, the orange curve shows you the price development of solar, and then there's a kind of Moore's law here for solar as well. That's about a 23% reduction in price per doubled capacity of installation, which is partially a result of economies of scale, but it's also part of the quite significant technological advances that have been made in the field. So in that sense, if I'm only showing you these two curves, the story looks incredibly simple, but it really is not. And there are so many things that are going on behind that I really have troubles even deciding what to talk about. You all know that solar is not a regular energy source, right? The sun comes up, the sun goes down, there are clouds there. Sometimes you have some sunlight, sometimes you don't, so it's an intermittent energy source, and you have all the problems coming up with how to deal with an intermittent energy source. These are quite significant problems, especially if you are to integrate quite large amounts of solar panels into your grid. And with the current installation rates, with the current amount of solar that we have, these are becoming very, very immediate problems, right? In California, they're dealing every day with it. In North Carolina, they're dealing every day with it. I'm from Germany. We've been dealing with those problems for a couple of years by now. It's something that is not solved at all. There are a lot of things to be done in research. Another one that just shows you how much the world in which solar lives has changed is this graph. This shows you the development of the prices with a little bit of a breakdown where the money goes. And the important part here is the margins curve, the highest one, right? When I started, we had margins in the solar sector for producing solar panels that were in the range of about 20%. So it was a very lucrative business. There were many solar manufacturers that were doing great. And then we entered a time when solar was largely overproduced. And one thing that happened is because the manufacturing process was developed so well, the margins dropped down. Now we're in the margins of about 5% range, and it's clear that it's nowhere as attractive as a business as it was like 10, 15 years ago. So this has been a complete game changer in the way that solar manufacturers have to operate. And we still want to reduce the prices even further, right? So we still need technological advances that go into how these solar panels are fabricated. So I really don't like the word of a paradigm shift in this, but I think it's really, we're facing a couple of them in the solar industry. The first is the massively changed manufacturing. The second is the dealing with the intermittency. There are more challenges. I don't want to go into those, but these two, I think, are already showing you what tremendous research efforts are still needed in order to make this, or to develop this further. So, with that, I want to show a couple of very nice pictures that Paul has given to me. These are related to the solar panels that are available. And on the top, you see the Summit farms. And this is only very small pictures. I think I have a better one coming up later on, just to give you an overview over how big this system is. There are about 200,000 solar panels installed in this system. And what this allows us to do is to do the research on one of these large solar plants, of which we will see many more in the future. And we can integrate this into how we do research. We can integrate this into how we do education. We can integrate this into courseworks. There's also some pictures of the solar panels that are available on the campus. And one thing that we are going to do is that we make the data that come out of all these plants available for research. That's going to be one of the first steps. There are many more people involved than me, Paul, and Joe in this, just to give you a bit of an overview over some of the people involved in this. You can see here, there's 2 slides of some of the people that are involved in this, and if you see them, you can talk to them about that. And with that, I'm just going to go through some of the pictures that Paul has provided me. This was a visit that we did to the Summit farm. This was in, was it December last year, November last year? I think early December last year. Unfortunately, when I was there, it was not as sunny as some of the pictures imply. It was, in fact, raining, which is not the best time to visit a solar panel, but it was still very impressive. This is, so just imagine 200,000 of these solar panels all lined up, and they're not only lined up like this, they are on trackers, so they track the sun on one axis, so they all move with the movement of the sun. I think about every 15 minutes they change their angle a little bit, and they do that not all at once, but in each row of them, or some of the rows at different paces. So it's quite interesting to watch that. I've been working in solar for 15 years, but I have never seen something like this before. So I enjoyed that very much. Yeah, this is a representation of the weather that we had at that particular day, and just some of the pictures for how these trackers work and what kind of electronics are necessary in order to have this system operated. We are not only going to get the data from all those plants, we're also going to get the data from, I think, 4 weather stations that are on the site, so we can correlate the output of the solar panels with temperature, wind speed, solar insolation, and so on. So there's quite a bit of research that we're already looking forward to doing, and there's a lot more that we can do with it, because this is not only a single solar panel, this is a great number of them. All right, so just showing you a couple more pictures of different possibilities that what can be done with solar. In the lower right is one of the things that is quite frequently done, to use solar panel to put a lot of shade on parking lots. That's, for example, one thing I've seen in ASU. Arizona State University recently also had a power purchase agreement. They bought a system for, I think, 40 megawatt, so not quite as big as the one at MIT, but Joe, right? They came to us and asked for some of our input for how to actually do this. So there's already more information and research that can be done on this, right? I mean, how do you do such a power purchase agreement? That's an interesting thing to ask as well. These are just a couple more examples for nice things that can be done with solar panel, and I hope that within this test bed we will see more of those develop on campus.
Thank you so much for the opportunity to talk about my Green Labs journey, which is such a great and easy story to tell. If I can find my slides, here we go. So you'll see the Green Labs team listed up there, because I did not take this journey alone. And for those of you who I have a pretty informed group here, but Green Labs is about what researchers can do to change their practices in their own labs, more or less by themselves, mostly simple, but not always, in order to save energy, save water, and save materials. And I've worked for many years at MIT on the building system side of our buildings, mostly in the area of lab ventilation. And I know how capable our researchers are, so I really wanted to see what they could do with the Green Labs program. So with this team, we came up with the idea of a contest. Again, we wanted it to be a very collaborative approach, with the researchers really teaching us along the way about how they'd like to do this, and also obviously being part of the MIT way. So we started the contest idea, and these are the lab groups that took the whole journey with us, and it's a beautiful picture to see all those people. The idea here was to educate the researchers along the way. We learned from them, but also to teach them about what a Green Labs program is, so that they could take that. Many of them are diplomats for us as they go and work in other places. And so the couple of things I just want to mention about this diverse number of lab groups. One is the top two, the winners of the contest. The Wang Lab, and Dan Preston is here. I'm going to talk about his innovative idea, and that was one of the contest awards was for innovation. Another was on most resources saved, and that's the Bruchette Lab that you see there in chemical engineering. But we really were hoping that we would get a diverse number of departments, and we were successful in that. And because these labs look very different, as they have different research missions, and a lot of the Green Labs programs that you'll see out there at other schools, a lot of times it can be oriented around life sciences. So we're really glad to see the ability to learn how it looks in the different kinds of laboratories. So we were thrilled about that. And you can see that chemical engineering really rules here, and we're really proud of them. Lisa Anderson sitting over there from the Prather Lab, and she was a lot of the reason for that, her and Brian Smith, for motivating chemical engineering. So how do you get people to take this journey with you? Very busy researchers who are already working many hours a day and have a lot of things to do besides just green their labs. And part of that is by frequent contact. And so we started out with lab group meetings. We used a mygreenlabs.org assessment tool, which individuals in the lab fill out. So Green Labs is not about one individual in the lab wanting to make changes, but really getting everyone in the lab, or a tipping point of people in the labs, to do these, to look at the Green Lab practices. So each person's performance is evaluated, and there's metrics that go along with that. It's very much like the LEAD kind of construct. And so we did this baseline assessment, and the tool is actually a really effective educational piece. And so in reviewing that assessment tool with the labs, getting to discuss with them where they're at now and what might work for the kind of research they do in their labs. And the lab walkthroughs so that we could become familiar with what's in their labs and give them more ideas about that. And then educational seminars. Mark Mullins from facilities talked about plug load monitoring. We looked at water. We had experts come in on water conservation, life cycle analysis, green chemistry. We tried to cover all the areas. And those touch points, having frequent contact of at least once a month with people out in the labs, was really critical for them to come along and not forget, oh yeah, right, we're supposed to be part of the Green Labs program. And this is just some of what we saw from those labs. So just a collage of some different things that were done. And you see the dishes up there, which is one of my favorites, actually. The Imperiali lab in biology said, oh, we used our seed funding. One of the things we did is we bought dishes for our kitchen. And so every time we would get together for lunch or remind the lab group that, oh yeah, we're trying to do good green practices, both at lunch but also back in the lab. So this kind of reminder was a really sweet, inspirational step, I felt, and I really love that. You can see some of the other techniques that were done there. And then the recycling program, lab folks are compassionate. The waste that they see in their labs really bothers them, and this very committed group really wanted to make changes around that. And the glove recycling was really demonstrative of that interest, in that folks from the chemical engineering department, for uncontaminated single-use gloves, those are latex and nitrile gloves, worked to find a vendor, worked out all the logistics of what would be required to do recycling, glove recycling, and really made that happen. And they're still carrying it on today. We have other departments joining, and so that's been a real success story to see that happen. And then finally, the Innovation Award, the Lab Energy Assessment Center. I mean, when we read this proposal from the Wang Lab, led by Dan Preston in mechanical engineering, about how they not just wanted to monitor the energy use in their own lab, but the idea was to put a kit together and train Europe so they could deploy and go out and measure the energy use, the plug load use, and the energy use in other labs. That really just, we love that idea. And so this center now exists, and Dan's here today. You can raise your hand, Dan, and we have Europe's who are going out and doing this kind of measurement. Why is plug load measurement important in labs? With all the different kinds of research equipment, it's not always clear about what the energy use is and how that equipment can be used optimally to not have a negative effect on research, but still save energy by turning things down, turning things off, and using them at their most optimal point. And what we also really loved about this idea was the visual. It talks there about the lighting and the fume hoods, and Dan worked with some, again, he did connections through people he knows to do some programming so they could use video cameras to look at what's the position of the light switches at any time and what energy goes with that, and what's the position of the fume hood sash so that they could tie energy use to that. So really bringing in not just the lab equipment, but also the building systems. So that's really having this LEAC, this ability to offer this to our new labs that have joined us. We're starting phase 2 of Green Labs. We set a goal of 8 labs, and miraculously, that's what we came up with, is 8 labs who will now venture with us for the next Green Labs program. And having this offering for them, I think, really helps get people engaged. So that's our Green Labs journey. Thank you.
Thanks, Pam, and thanks to our panelists. So this actually spurred an idea in my mind in terms of monitoring energy use in labs with all the various types of equipment, and that is labs are very expensive to renovate and to build. And we base it upon the heat loads of all this equipment that all of our engineers think we turn on all the time, which if we can get evidence that says, you know, we only run all the equipment at peak load at 25, we can save a lot of dollars and right-size how we renovate a lot of these labs. So I had 1 or 2 questions for the panel, and then we can turn it out to the rest of you. So one of the important themes and ingredients during our conference call we had was, you know, sort of getting people to come along with you in this journey. So it's a lot like picking a lab partner in school. And you want to pick a lab partner that you know you're going to get an A, right? That they're going to do as much work as you are. So if anyone wants to kind of maybe answer the question of, were there any moments of truth when you were picking your lab partner that you were like, this is absolutely going to be a winner in terms of the area that you were focused on?
Well, for me, it was Neve Kelly. I think she's still here. Neve's really passionate about especially recycling and materials management. So we started off initially and then had the bigger team come and join us because we knew we didn't have expertise in all the areas that we needed.
Great.
Yeah, I can add. Yeah, so you know, our whole experience with Patrick and Seth and others has been, and Paul has been, you know, very, very positive. So you know, we thought, you know, we'll just put this thing there and get some data, and the amount of help and sort of the engagement we got from them right off the bat, you know, it was really, you know, it was sort of, you know, we knew we'll be successful. Either way, we'll basically get the data, and we can then make the assessment of the technology.
I can say for myself, as a PhD student, trying to find a home, being able to collaborate with the Office of Sustainability was kind of a defining moment for when the research took off, because it created, it opened the door to a whole new set of connections and resources. So thanks, Midos.
So from my perspective, I think I never really consciously picked a partner in this. It was more like getting to know people and trying it out. So I think a lot of the credit for, in my personal perspective, for why I'm here today goes with Jeremy and with Rachel, 2 of the students in our lab who, without them, I would have never learned about these activities that are going on here. And then I got to know all of you guys, and so far it's been great.
Thanks. So the second question we had was really kind of based upon Julian's comments this morning. So in testbed environments, building this trust factor is critical. And once you have that trust, we start to engage in these dialogues that we've never had before with people that we've never met before. And I think the audience would be really curious about, you know, were there sort of these aha moments that, you know, people were starting to ask questions that weren't asked before, or that a dialogue of certain people from different backgrounds brought a different outcome to your work?
Yeah, so I can say 2 examples of kind of opening new dialogues were with the Office of Procurement and more recently the Property Office. I'll just explain the Property Office because I don't know if anyone is here from that office, which is relatively small. So the Property Office tracks products that are housed on campus that are above a certain value amount, so say over $3,000. They know when the product is deactivated and leaves campus. So we engaged with them in a discussion, how could we use this data for the purpose of sustainability? And so from my perspective, my immediate thought was, oh, we know when it came into campus from your data, and we know when it left campus, so now we know the lifetime of these products, and how lifetimes impact waste is very important. So kind of just having that dialogue opened up, in their minds, a lot of opportunity for their data that they hadn't put to use before. So that's just one example.
And I think, from our angle, we learned a lot about the whole MIT Waters network. Initially, I passed by the cogen plant every day, and I think it's a cogen plant. But that whole experience of going through, the whole flow chart and the flow diagram, I think presented us many other opportunities, and I think deciding where we would do which cooling tower we would use a pilot for, also presented to us a lot of knowledge on what are all the other cooling towers in the institute, what are they actually doing. Potentially there were things that were used for building cooling. It's not just for power plants, so that opened up, we could also look at buildings. We had this sort of inkling, but this was sort of more helped us solidify that idea that there's another market beyond power plants. And we also found some very old maps of MIT, which I hadn't looked at in the cogen plant. So it was all a fun experience.
For us, it was, with the contest, we had a very specific construct that we just kind of made up, but then we realized that was going to work really well for continuing the Green Labs program. So kind of using that contest as a pilot and a foundation to build off of.
So I'd like to open it up to the audience for any questions for any of our panelists.
I was wondering if you'd be able to share some stories of the people who you met in North Carolina and how that may have opened more on the theme of opening up new dialogues with where greater understanding is necessary among folks.
All right. Okay, thank you for that question. I was just thinking about for answering the last one, and I didn't have it quite worked out. So I'm trying to tell a couple of stories that are a little bit intertwined. Before I started being involved in the testbed activities, we have been discussing a very serious problem that we've been facing in the lab, and not only in ours, but with many different solar labs. And this problem is that despite quite significant innovation that we've seen in the field, it has been extremely difficult to get this kind of innovation installed anywhere. And one of the reasons is related to the graph that I've shown you for these tremendous changes that the solar industry has gone through. These changes have resulted in a very conservative industry, and in a conservative industry, it is hard to innovate. They are very, very conservative. They are very, very distrustful of changes. So if you have a new technology, it is very difficult to get it into the market. And one of the problems that we were facing was to try and break this cycle. How do you even do that? So we drove to New York and talked to people from Goldman Sachs about that. And one of the things they told us is that if there were someone who could provide data about new products and show that they're working well in comparison with an established product, that would be something that would build trust, and that would be something that would be possible to bring new innovation into the market. And then the solar testbed opportunity came up, and we had a chance to talk to the developers down there. And I've been asking the exact same question to the developers, and been asking, so do you think it would be possible to open up an additional array and put some of our products that we are developing here? And they were thinking about it, and they say, yeah, we could do something like this. It would be really interesting. So the dialogue with the developer, with Dominion, and also with, how do they call it, Sun Energy One, that has been really interesting in kind of shaping this question, kind of learning how decisions are really made for what kind of solar panels, what kind of technology is installed in the field. And the second related experience to this was when we were, 2.5 weeks ago at the ribbon cutting ceremony for the event. We got to interact with a lot of the people from the community there. And the kind of concerns that they had with solar, they were completely new to me. A couple of them asked me questions that I had never thought about. Regarding the amount of sunlight that reaches the ground underneath the solar panel and how that influences the crops that you can grow underneath them. And I had to get back to them and tell them, you certainly know more about that than I do. So I should ask you that question. But yeah, these kind of perspectives, if you're sitting in the lab or in front of your computer, you don't typically get to hear those. So I think that these interactions are extremely valuable in terms of shaping how to think about these kind of projects.
Yes, two very powerful examples. And I remember the day we were in the trailer with Marius and Joel, two of our researchers here, the developer who's been building solar for a living, Dominion Energy, the largest, one of the top 3 largest utility companies in the country, if not the world. And they learned things that day and heard questions that they haven't heard before. And they all went back to their folks and said, there's an issue with the way that research scales. Why are we using 20-year-old technology in these large-scale plants? And that panel that you see sitting right there is 20-year-old technology. And why is that? And why don't developers use them? And why don't large-scale utility companies invest in research? They all went back to their parent companies just by the fact that there was a conversation that happened in that room that never happened before. So I think that's really the key essence of reaching out and talking to people that you normally wouldn't have talked to before. And these testbed environments are exactly about that. Any other questions from folks in the audience? So the last, how are we doing on time? Do we have a couple? So I think that one of the other themes that really came out of us kind of going through these testbed examples was this idea of hidden benefits. So I think there were some benefits realized, and I think you've heard through their stories, but I'd like to just summarize it. That there were some hidden benefits that the folks didn't originally intend to come out of these testbed environments. And the hidden benefits were cost savings, operational excellence, whether it's in transportation or in the laboratories or people striving for things in their professional careers. People found a better approach to the way that they were thinking about their research or the way that we think about our operations. Much better information came out of this. So I think that there were data sets that all of you wanted to get as part of your work, and data got better, which benefits us both on both sides of the coin. More resources, so the Institute is putting more and more behind these partnerships. Together we can do more. The expanded networks that we realize through each other that we've never had access to in our own professions. Some professional recognition within our own groups. Folks around all of you are recognized within your organizations as thought leaders in sustainability. And then ultimately, the potential commercialization of an idea or a world-changing idea in terms of the way that we build large-scale solar farms or the way that we reduce plumes and reduce water in our energy-generating assets. So with that, I think we'll just maybe some closing thoughts. The real key to success of the test bed is all of you. I think we all knew that 2 years ago, and clearly it's happening. We saw the 20 adventure cards up there. There's been some pretty amazing adventures that you've all taken us on. And I think that my 18 months here at MIT, what I've seen is that the people who succeed the most here every day are those that can access the intellectual capital that sits all around this room. So those people that can make those networks, whether it's faculty, researchers, staff, operations folks, and boldly activating their networks. Those are ultimately the people that result in these types of world-changing improvements and ultimately the success of their career. So the next phase of our day today is to figure out what we're going to be working on this next year so that when your colleagues or some of you come up next year to present your test beds, We're going to be reaching out to kickstart a conversation about matching campus-based questions with more opportunities for research and education. So there's going to be a little bit of a matchmaking session here in the next phase, and we're looking forward to all the great things that you're going to be up here sharing with us next year. So thank you to our panel. Great job.